Welcome back. In this tutorial, we're going to prove the compound angle formulae. It's going to be a bit long because we're going to start by discussing some concepts that we need to remember before we do the proof, and also look at the steps that we're going to follow. Then after that, we do the proofs for the four compound angle formulae. When two angles are added or subtracted, they are known as compound angles. When two angles are added or subtracted, they are known as compound angles. All compound angle formulae are derived from this one. Cos A minus B is equal to cos A times cos B plus sin A sin B. Right? This is a compound angle. Right? What did we say? We said when two angles are added or subtracted, they're known as compound angles. So here we've said A minus B. So this is a compound angle. Right? Cos A, cos B. Just follow this order. We have A and B. So we have A, B. So it's going to be cos, cos. Cos A, cos B. And then here you change the sign. In the compound angle we're separating. So here is going to be plus. So cos A, cos B plus sin A, sin B. So we're going to discuss each compound angle formula like this. And then after that, we're going to prove them. So these are the following compound angles. We say this one is formula 1. Let's call it formula 1. This is from where all the compound angle formulae are going to be derived. The other one is this one. Cos A plus B. See now? It's cos A plus B. Follow the order. A, B, A, B. Then it's cos A, cos B, sin A, sin B. But now the operation changes. Here is plus, here is minus. Okay? Cos A, cos B, sin A, sin B. And then we have also sin A plus B. So if you sin A plus B like this, the operation is maintained. You see we have plus here and also have plus here. You see we have our A, B, A, B. It alternates. It's sin A cos B, then cos A sin B. Okay? Sin A cos B, cos A sin B. But now the operation in the bracket here and then this one, they are just the same. Just like we have sin A minus B, the operation here is minus, the operation here is minus. We have AB, AB. Then we alternate this, sin A, cos B, cos A, sin B. Okay. These are the four compound angles we're going to prove. We're going to start by proving formula 1, and then these other three are going to be derived from formula 1. These are the few things that I want us to discuss before we do the proof. Right? X and Y coordinates in the Cartesian plane can be written in terms of trigonometric ratios. Okay, let's check this. Let's say we have our terminal ray here. Let's call it P. Right? Remember from trigonometry, this is X, this is Y, then this is R. Okay, right? And then from this we know that we have cos theta. Let's say this is angle theta. So cos theta is equal to X over R, and then sine theta is equal to Y over R. So then from these we can get our X and Y multiplied by R both sides. R cos theta is equal to X. Then here R sine theta is equal to Y. So here we can write our X coordinate as R cos theta. Then we can write our Y coordinate as R sine theta. Please remember that. So the X and Y coordinates in the Cartesian plane can be written in terms of trigonometric ratios like this. Okay, so X is R cos theta, Y is R sine theta. Angles are measured anti-clockwise from the, from the positive x-axis. From this side, angles are measured anti-clockwise from the positive x-axis. Remember that. So when we're measuring angles, we're starting from the positive x-axis and we move anti-clockwise like this. Then the distance formula, you have to remember the distance formula. We're going to use two formulae here to prove this. There is the distance formula and the cosine rule. Okay, distance formula, for example, if we want to find PQ, that's distance PQ, how do we do it? Y at P minus Y at Q all squared. Then we have X at P minus X at Q all squared. You see that? Okay, that's the distance formula. We're going to use it later. right? And then the other one you have to remember is the cosine rule. Remember the cosine rule. If you're looking for this side, which is PQ, you can say PQ squared is equal to OP squared, which is this side, plus OQ squared, and then minus 2 OP OQ cos theta, if this angle is our theta, cos theta. That's the cosine rule. Check, the subject here is p squared for the cosine rule. Even for the distance formula, the subject is p squared. Okay, so we can easily find pq squared using the distance formula, and then find pq squared using the cosine rule, and then equate these two. That's what we're going to do, right? And then remember, sine squared theta plus cos squared theta is equal to 1. This is a trigonometric identity that we do in grade 11. Sine squared theta plus cos squared theta is equal to 1. And then the other crucial concept we have to remember are the co-ratios, right? Or co-functions. Some people say co-ratios, some people say co-functions. Right? Cos 90 minus theta is equal to sine theta. Remember that? And then cos 90 plus theta is negative sine theta. And then sine 90 minus theta, that is cos theta. And then sine 90 plus theta, that is cos theta. Please remember these four. And then the last things that we need to remember are the negative angles. Negative angles, always remember that negative angles, these are the angles, we measure them clockwise. Remember, I said angles, we measure them anti-clockwise. When we measure negative angles, is clockwise, is clockwise. So these are the negative angles. Remember that in the fourth quadrant, it is cos theta that is positive. The other two, tan theta and sin theta, negative. So you can use this to remind yourself about the negative angles. So cos negative theta is cos theta, it's positive, and then sin negative theta is negative sin theta, and tan negative theta is negative tan theta. Now let's look at the steps now. The steps. This will assist us to understand this whole thing. Okay, so I'll take you step by step, and then after that we're going to do the proof. Right? What do we do? Right? Construct a unit circle. A unit circle means this is a circle with a diameter of 1. Okay, this is a circle with a diameter of 1. That's a unit circle with center O at the origin. Then after that, you indicate ray OP with angle B from the positive x-axis. Remember we said we measure angles anti-clockwise from the positive x-axis. So you write the coordinates of P. We've talked about this, how we write the coordinates. We can write the coordinates x and y in terms of trigonometric ratios like this. So this is our ray OP. Okay. Remember, we want to prove cos A minus B. So we're going to use A and B for our angles. So we've constructed the first ray. And then we go to the next one. Construct ray OQ, means from the origin to the circumference there. Okay, with an angle A from the positive x-axis. We measure our angles from the positive x-axis. Again, we have our x and y coordinates in terms of trig ratios. So we have angle A, which is the bigger angle, and angle B. So what would be this angle which is formed between OQ and OP? It's going to be A minus B, okay? Right, but let's continue with our steps. So now what you do, join P and Q. We are constructing the line segment PQ. In this case, it's like the chord of the circle. So we have PQ there. We have formed a triangle. Do you see that we have formed triangle POQ? Then what is the size of angle POQ? Indicate angle POQ as A minus B, right? So this is the angle we're interested in, and then this is a triangle we're interested in, POQ, triangle POQ, right? And then what do you do after we've done all this? We have to find PQ squared using the distance formula, and find PQ squared using the cosine rule, and then we equate them. Create two equations of finding PQ using the distance formula, and then using the cosine rule, and then after that equate the two equations and simplify. Right, that's what we have to do. I want us to find PQ squared using the distance formula, and then after that we're going to find PQ squared using the cosine rule, and then we do the equating and simplification. From the distance formula, check here, we said P is R cos B, then R sin B. This is a unit circle, our radius is 1. So meaning that our R is 1. So that's why we have cos B sin B. Even this side we have cos A sin A because our R is 1. So that's why R is disappeared. Let's continue from there. PQ squared is equal to our y at P sin B. So it's going to be sin B minus our y at Q is sin A squared plus our x at P, that is cos B, and then our x at Q, that is cos A, and then squared. Okay, right now we have to simplify this or expand this. So PQ squared is equal to, you can do the long way. This means sin B minus sin A, right, times sin B minus sin A. That's the first one. So if you expand it using a FOIL, you must get sin squared B minus 2 sin B sin A, or sin A sin B, then plus sin squared A, right? And then the next one, this one, which is cos B minus cos A times cos B minus cos A. And you can do that using a FOIL. You will get cos squared B minus 2 cos B cos A, right, plus cos squared A, right? Right, take note of this. We have sin squared B plus cos squared B. We have sin squared A plus cos squared A. Sin squared B plus cos squared B, that's 1. Remember that? Sin squared A plus cos squared A is another 1. We have PQ squared is equal to 1 plus 1. So this combination has given us 1. Then this combination has also given us a 1. And then we remain with negative 2 sin B sin A minus 2 cos B cos A. We can factor out negative 2 here. For this, we can factor out negative 2. So it becomes PQ squared is equal to 2 minus 2, and then sin A sin B plus cos A cos B. Okay, let's call this equation 1 for now. Okay, we'll come back when we are equating the two. Let's find PQ squared now in terms of the cosine rule, right? This is our equation 1. Please write it down. And then in terms of the cosine rule, so we have P squared is equal to OP squared plus OQ squared minus 2OP OQ cos angle POQ. So PQ squared is equal to OP and AQ are radii. Remember, say that this is a unit circle, so our radius is 1. So it's 1 squared plus 1 squared. Okay, minus 2. OP is 1. OQ is 1. Then cos angle POQ. This is the angle A minus B. So it's going to be A minus B, like this. See that? Let's simplify this. PQ squared is equal to 2 minus 2 cos A minus B. So this is equation 2. Now we have two equations where PQ squared is our subject. We used the distance formula to get equation 1. We use the cosine rule to get equation 2. So now we have to equate these two equations. We got PQ squared from the distance formula, that's equation 1. We got PQ squared from the cosine rule, that's equation 2. Now you can equate these, okay, because they are both equal to PQ squared. So let's equate those. And then 2 minus 2 is 0. So we're left with negative 2 cos A minus B is equal to negative 2 sin A sine B plus cos A cos B, right? And then we can divide by -2 on both sides of the equation. Therefore, cos A minus B is equal to sine A sine B plus cos A cos B. Then this can be written like this: sine A cos A minus B is equal to cos A cos B. Addition is commutative, so then sine A sine B. We can move things around like this. Okay, so we've managed to prove our formula 1. So we have to prove the other 3, okay, using formula 1 now. So you have to remember our cofunctions and the negative angles. We're going to use that a lot for the next part of our lesson. Let's prove that cos A plus B is equal to cos A cos B minus sine A sine B. How can we do that? So we have to make sure that this looks like this. Okay, how can we do that? If we say cos A minus negative B, okay, do you see that this is equal to cos A plus B? This is cos A plus B. But now we have a minus, and then our B is like our negative B. This B is now like this negative B here. This is equal to cos A plus B. Okay, so to prove that cos A plus B is equal to cos A cos B minus sine A sine B, we can use this because these two things are equal. So it means cos A plus B. Okay, so what we're going to do, where there's B, we're going to put negative B. Where there's B here, we're going to put negative B. So it's going to be cos A cos negative B plus sine A, we have sine A, and then sine B, our B is negative B here, so we're going to say sine negative B. Okay, right. Now remember negative angles. Cos negative B is cos B, so this is just as cos A cos B. But sine negative B is negative sine B. So it will change this sign and become minus. Minus sine A sine B. Done. We have done the proof for the second one. Let's go to the third one. Now we have sine A plus B. Now we have to use our cofunctions here. Okay. Relationship between cos 90 minus theta or cos 90 plus theta and sine theta or cos theta, something like that. So now remember, we want our ratio to be like this: cos A minus B. And then sine A plus B is the same as cos 90 minus A plus B, isn't it? Remember that cos 90 minus theta is equal to sine theta. Cos 90 degrees minus theta is equal to sine theta. So our angle here, now theta is like A minus B, right? And then from this also, we can see that we can remove this bracket and we get cos 90 degrees minus A minus B. Okay, we have removed the bracket so that we have something like this, where we have A minus B. Okay, A minus B. This one is almost the same as that. You can say this is A, this is B, but we may not simplify this because we want the other one to be a co-ratio. So when it's like this, we can say this is cos 90 degrees minus A, like this. Now we have a co-ratio there, and then minus B like that. You see that? So our A is like the 90 minus A, and then our B is just like the B, right? And then this is equal to, we're using this part now, is cos A is cos 90 minus A, then cos B, okay, and then plus, then sine A, our A is 90 minus A, so it's sine 90 degrees minus A, and then sine B, then sine B like that, okay, right. Then cos 90 minus A, that is sine A, isn't it? Sine A, then cos B, alright? And then sine 90 minus A, sine 90 minus A, that is cos A. So plus cos A, and then sine B. Okay, we've proved that, right? Sine A plus B is equal to sine A cos B plus cos A sine B. Let's do the fourth one. Now I want to prove that sine A minus B is equal to this. We're using this. Okay, so how can we make this one look like this? Again, we use the co-ratios. So cos 90 degrees minus A minus B. Okay, if we check, this is the same as sine A minus B, isn't it? This is the same as A sine A minus B. Okay, let's remove this inner bracket. So cos 90 degrees minus A plus B. And then now, what do? We have to say 90 degrees plus B minus A, so that we have something like this. Our A is going to be 90 plus B, and then our B is going to be like the A, isn't it? So we're going to say cos 90 degrees plus B, and then minus A, like that. Okay, right, come back to this, use this. This is equal to cos 90 degrees plus B, and then cos A, right? Then plus this plus, then sine 90 degrees plus B, and then sine B. In this case, our B is like this one, A. Okay, right, and then cos 90 plus B is negative sine B. This is negative sine B, right? And then cos A, then plus sine 90 plus B, that is cos B sine A, right? Then you can rearrange this. You can start with this and say sine A cos B, and then minus cos A sine B. Okay, so we've proved that sine A minus B is equal to sine A cos B minus cos A sine B. This is how we prove these four compound angle formulae.